Dear students, welcome to mathematics online classes. In the last video, we did up to problem number 9. Now, problem number 10 we will solve. Problem number 10 is given as sin inverse of x whole square. Problem number 10 in the exercise 7.6, it is given as sin inverse of x whole square. What is sin inverse of x whole square? Here, I is equal to, we take integration of sin inverse of x whole square into dx. See, if you look into the problem, it looks like integration of single function. Integration by parts means it is integration of product of two functions. Yes, we have to be careful here. You should not get confused how to integrate this like that. We need to integrate with the integration by parts technique only. Sin inverse of x whole square into 1 into dx it is, where sin inverse of x whole square is taken as first function and this one algebraic function it is taken as second function. According to the Euler rule, you see inverse trigonometry will come first followed by algebraic functions, that is a second. Okay, now we are going to solve with the integration by parts. I is equal to that integration of f of x into g of x. I will not write repeatedly again and again. I am going directly first function as it is, means sin inverse of x whole square as it is, into integration of 1 with respect to x minus of big integral differentiation of sin inverse of x whole square with respect to x into integration of 1 with respect to x. Whole integral is with respect to x. This is I is equal to sin inverse of x whole square, integration of 1 with respect to x is x minus of big integral differentiation of sin inverse of x whole square. We need to differentiate for 2 first. So this is 2 into sin inverse of x, chain rule we are using, into differentiation of sin inverse of x, that is 1 by square root of 1 minus x square. Now into what? Into integration of 1 with respect to x, that is x into dx. Okay, here we will write I is equal to sin inverse of x whole square into x minus of 2 we will write outside into sin inverse of x by square root of 1 minus x square into x dx we have. Okay, here how will you solve? Let us go with the substitution method first here, because sin inverse of x differentiation is 1 by square root of 1 minus x square. Okay, let us put t is equal to sin inverse of x. This is dt by dx is equal to 1 by square root of 1 minus x square. This is dt is equal to 1 by square root of 1 minus x square into dx. Okay, then sin inverse of x is equal to, we will substitute t. What about this x? Using this substitution, I can write here x is equal to sin t. Okay, I is equal to sin inverse of x whole square into x, that is completed part, we no need to do anything with that, that will be as it is, minus 2 into integral of sin inverse of x means t, x means sin t, into 1 by square root of 1 minus x square into dx is nothing but dt. Next what to do? Next again we will go with the integration by parts technique here. According to the Euler rule, here two functions are there. First is t and sin t. T is algebraic function, sin t is a trigonometric function. See, algebraic comes first followed by trigonometric. So this one is first function, this one is second function. I is equal to sin inverse of x whole square into x minus 2 will get multiplied to both the term, keep this outside. First function as it is, integration of sin t with respect to t minus of big integral differentiation of t with respect to t into integration of sin t with respect to t into integration of sin t with respect to t, whole integral is with respect to t. This is x into sin inverse of x whole square minus 2 into t as it is. What is integration of sin t? It is minus cos t. I will write minus here, minus cos t, minus of big integral, differentiation of t with respect to t is 1 into integral of sin t is minus cos t, minus into minus plus cos t into dt. Okay, this is x into sin inverse of x whole square minus 2 into minus, that is minus minus plus 2t cos t plus of integration of cos t we can write, that is, sorry, it is not plus, minus 2 into plus become minus 2 into integration of cos t dt. We have I is equal to x into sin inverse of x whole square plus 2t cos t minus 2 into, what is integration of cos t? It is sin t plus c. But you see, this is in terms of x, this is in terms of t. Answers we should not keep in terms of t. You should bring it back to the original variable, that is x. We will, for that we will use the substitution. Substitutions, you see, t means we will write sin inverse of x, and this sin t means we will write x. What about this cos t? Yes, again, as I explained in the previous class, I will write cos t is equal to, otherwise cos square t is equal to 1 minus sin square t, using the formula cos square theta plus sin square theta equal to 1. Cos square t is equal to 1 minus sin square t. This is cos t is equal to square root of 1 minus sin square t. This is square root of 1 minus sin square t. Sin t is x, so this is x square. Okay, here integration I is equal to x into sin inverse of x whole square plus 2 into t means sin inverse of x, cos t means square root of 1 minus x square minus 2 into sin t is x minus 2x plus c. We can leave this here. This is about question number 10 in the exercise 7.6. Now we will go to the next, that is question number 11. Question number 11 is given as integration of x into cos inverse of x by I is equal to, let us take like this, I is equal to integration of x into cos inverse of x by square root of 1 minus x square into dx. Okay, how will you integrate? Before integrating, let us go with substitution method here, means before integrating by integration by parts, let us go with substitution technique, because differentiation of cos inverse of x gives me 1 by square root of 1 minus x square, that is why. Okay, let us put t is equal to cos inverse of x. This is dt by dx is equal to, what is the differentiation of cos inverse of x? We know it is minus 1 by square root of 1 minus x square. We have minus dt is equal to 1 by square root of 1 minus x square into dx. Okay, I is equal to integral of x means what then? With this substitution we can get what is x. We have x is equal to cos t. Yes, x is cos t, cos inverse of x is t, 1 by square root of 1 minus x square into dx is dt. You will write minus outside into dt it is. Now we will integrate it by integration by parts. Okay, to integrate it by parts, we should choose which one is first function and which one is second function. According to the Eilert rule, this is trigonometric function, this is algebraic function. Algebraic should be considered first, followed by trigonometric functions. Okay, this is minus of integral of t into cos t into dt. Okay, minus outside. We will integrate it by parts now. We will put inside the bracket because minus get multiplies to both the terms. First function as it is, integration of cos t with respect to t minus of big integral differentiation of t with respect to t into integration of cos t with respect to t whole integral is with respect to t. Minus will get multiplied with both plus into minus, minus t into integral of cos t is sin t, minus into minus plus into integral of integration into differentiation of t with respect to t is 1 into integral of cos t with respect to t is it is sin t, integrating with respect to t. Okay. Now I is equal to minus t into sin t, integration of sin t is minus cos t plus c, integration completed. But the thing is that we should not keep the answers in terms of t, we should take it back to the original variable. T means cos inverse of x, we will substitute. Cos t means x, we will substitute. But what about sin t? Yes, for that we will use the formula sin square t plus cos square t is equal to 1. Sin square t is equal to 1 minus cos square t. We have sin square t is equal to 1 minus of cos t is x, so this is x square. Okay. We have sin t is equal to square root of 1 minus x square. Now substituting it back, I is equal to minus of t is cos inverse of x, sin t is square root of 1 minus x square, minus of cos t is x plus c. Minus is common, we can take outside, minus of x plus square root of 1 minus x square into cos inverse of x plus c is the answer here. Problem number 11 completed. We will take the next question, that is problem number 12. X into secant square x. Problem number 12 is x into secant square x. I is equal to integration of x into secant square x into dx. Okay. What are the functions? One is algebraic function and the second one is a trigonometric function, secant square x. It is trigonometric function. Which one should be taken first? Algebraic should be first and trigonometric should be second. Okay, it is in correct order. Okay, I is equal to first function as it is integration of secant square x with respect to x minus of big integral differentiation of first function with respect to x into integration of second function secant square x with respect to x. Whole integral is with respect to x. I is equal to x into, what is integral of secant square x? We know differentiation of tan x is secant square x. So integration of secant square x is tan x. X into tan x minus of integral of differentiation of x with respect to x is 1 into integration of secant square x is tan x into dx. Okay. I is equal to x into tan x minus of, what is integration of tan x? We know integration of tan x is log of mod of secant x plus c. You can write with the cos also, no problem. Simple one it is. Now we will move on to the next heading, that is not the next heading, next question it is, that is question number 13. Question number 13 is tan inverse of x. How will you integrate tan inverse of x? That is by the integration by parts. Okay, I is equal to integration of tan inverse of x into dx. Single function is there. To integrate it by parts method, what we do, we will take into 1, tan inverse of x into 1, where tan inverse of x is considered as first function and 1 is considered as second function. This is according to the Eilert rule, where inverse trigonometry will come first followed by algebraic function. Okay. I is equal to first function as it is, integration of 1 with respect to x minus of big integral differentiation of tan inverse of x with respect to x into integration of 1 with respect to x. Whole integral is with respect to x. I is equal to tan inverse of x as it is, integration of 1 with respect to x is x minus of big integral differentiation of tan inverse of x is 1 by 1 plus x square into integration of 1 with respect to x is x into dx. Okay, I can write here I is equal to x into tan inverse of x minus of integral of 1 into x is x by 1 plus x square into dx. Now how will you simplify here? We can integrate it by substitution method. By substituting t is equal to 1 plus x square, it gives us x in that. Okay, here you substitute t is equal to 1 plus x square. Differentiating the function with respect to x, we have dt by dx is equal to 0 plus 2x. This can be written as 1 by 2 into dt is equal to x into dx. Okay, I is equal to x into tan inverse of x minus integral of x into dx is 1 by 2 into dt. 1 by 2 I will write outside. 1 by 1 plus x square means we are substituting t into dt. Okay, this is I is equal to x into tan inverse of x minus 1 by 2 into 1 by t integration is log of mod of t plus c. This is x into tan inverse of x minus 1 by 2 into log of mod of what is it t? T is 1 plus x square plus c. Integration completed. Next we will take question number 14. It is given x into log x whole square. Question number 14 is x into log x. Log x square is there. For log x square is there. Okay. Now I is equal to, we have integration of x into log x square into dx. Here are two functions are there. One is algebraic function, another one is a logarithmic function. According to the Euler rule, which one should be taken first? Logarithmic comes first and algebraic function comes next. I is equal to integration of log x whole square into x into dx. Okay, integrating it by parts. I is equal to first function as it is, log x whole square into integration of x with respect to x minus of big integral differentiation of log x whole square with respect to x into integration of x with respect to x. Whole integral is with respect to x. This is log x whole square, integration of x with respect to x is x square by 2 minus of big integral. What is the differentiation of log x whole square? For differentiating 2 using chain rule, it is 2 times log x into differentiation of log x means 1 by x multiplied with the integration of x means x square by 2, this dx will be there. You see 2 get cancelled, 1 time x get cancels out. We have x square by 2 into log x whole square minus integral of, then what I have here again, I have log x into x dx. Log x into dx, how will you integrate? Once again we will go with the integration by parts rule. Which one should be taken first? Logarithmic first followed by algebraic. We have here x square by 2 into log x whole square minus of, we will write it inside the bracket because minus will get multiplied. First log x as it is, integration of x with respect to x minus of big integral differentiation of log x with respect to x into integration of x with respect to x. Whole integral is with respect to x. Okay. we have here, this is x square by 2 into log x whole square minus of, minus will get multiplied with these two, we will write here plus into minus, minus log x into integration of x with respect to x is x square by 2, minus into minus plus big integral as it is, differentiation of log x is 1 by x into integration of x with respect to x is x square by 2 into dx. One time x get cancels out. We have I is equal to x square by 2 into log x whole square minus log x into x square by 2 plus of 1 by 2, I will write outside, integration 1 by 2 into integration of x with respect to x. I have I is equal to x square by 2 into log x whole square minus x square by 2 into log x plus 1 by 2 into integration of x with respect to x is x square by 2 plus c. Integration completed. What is common here? X square by 2 is common, we can take it outside. X square by 2 into log x whole square minus log x plus 1 by 2 plus c is the answer here. This is about problem number 14. Dear students, I am telling you, please make a note of all the integration formula. Integration formula are very much important. You will be forgetting, you need to practice every day. And along with that, make a note of all the formula. Those are very much important, very much needed. Not only here, in the next chapter also it is required. That is applications of integrals, then it is required in differential equations also. That's why make a note of all those and practice well. Problem number 15, x square into log x. I want you to solve this. Problem number 15, x square plus 1 into log x. X square plus 1 into log x. One algebraic function is there, another one is a logarithmic function is there. X square plus 1 you take it as one function and log x as another one function. According to the highlight rule, log x should be taken first, followed by x square plus 1 as the second function. I hope all of you will do this. Problem number 15 is left to you. Now, to solve problem number 16, we need to know the concept. Concept is, suppose this is integration by parts only, but directly we can put the answer if you know that step. Even if you don't know the method I am going to explain here, with the integration by parts only we can solve. But as it is a special one, directly we can put the answer. Better we should know it. Integral of the type. Integral of the type, that is integration of e raised to x into f of x plus f dash of x into dx is there. How will you answer this? Integral of the type means you observe here, integral of exponential function which is multiplied with a function plus its differentiation, f of x plus its differentiation is there. Then we can directly write the answers for this. Now let us say, what is this? I will write the answer here. Otherwise, here you remember this, integration of e raised to x into f of x plus f dash of x with respect to x is equal to e raised to x into f of x, integration completed, plus c. This is the answer for this kind of problems. E raised to x is there, multiplied with a function plus its differentiation. This answer is e raised to x into f of x plus c. How is this? I will tell you. See, I is equal to integration of e raised to x into f of x plus f dash of x into dx is there. I will write it as two functions. First one is e raised to x into f of x plus e raised to x into f dash of x, integrating with respect to x. Now let me write it as sum of two integrals. First one is integral of f of x into e raised to x into dx, and the second one is integral of e raised to x into f dash of x into dx. Second one I will not do anything. First one I want to integrate. According to the Euler rule, I will take this f of x as first function and exponential function as the second function. Now you see what happens to this. First function f of x as it is, integration of e raised to x minus of big integral differentiation of first function f of x can be written as f dash of x into integration of e raised to x with respect to x. Whole integral is with respect to x, plus this will be kept as it is, plus integration of e raised to x into f dash of x dx. Okay, I is equal to, this is I is equal to f of x into integration of e raised to x is e raised to x minus of integral f dash of x into integration of e raised to x is e raised to x into dx, plus integration of e raised to x into f of x into dx. You see here, these two are same, multiplied with minus, multiplied with plus, these two get cancels out. Integration completed. See, so we have I is equal to f of x into e raised to x plus c. We used to write it as I is equal to e raised to x into f of x plus c. So this is what the answer is. This is what the proof is. Okay, let me solve a problem on this. I will take one problem on this, that is example 22. Let me take example 22 here. It is given, find first one, integration of e raised to x into tan inverse of x plus 1 by 1 plus x square into dx, and second one it is given as x square plus 1 by integration of x square plus 1 by x plus 1 whole square into e raised to x into dx. They have given you. Okay, now how will you solve this? It is very simple. First one you say, is it not in the form integration of e raised to x into f of x plus f dash of x? Yes, it is. F of x is equal to tan inverse of x, then what will be f dash of x? F dash of x means its differentiation, that is 1 by 1 plus x square. We know integration of e raised to x into f of x plus f dash of x into dx is equal to e raised to x into f of x plus c. Okay, now integration of e raised to x into tan inverse of x plus 1 by 1 plus x square into dx is equal to e raised to x into tan inverse of x plus c. Finished. Such a simple question it is. Okay, now here we will solve. Integration of e raised to x I will write first. It is given as x square plus 1 by x plus 1 whole square. Very simple it is. First of all, we have to bring it to the standard form, that is, we have to bring it to the form e raised to x into f of x plus f dash of x. For that what we do, e raised to x we keep as it is, which is multiplied with x square minus 1 plus 2 I will write. Here plus 1 is there, no? Plus 1 is there. We will write that plus 1 as minus 1 plus 2 divided by x plus 1 whole square into dx. Now integration of e raised to x into, here we will split it into two terms. First one is x square minus 1 by x plus 1 whole square, and second one is 2 by x plus 1 whole square integrating with respect to x. Okay, This is integral of e raised to x into, we can simplify here. Numerator you see it is in the form a square minus b square. A square minus b square can be written as a plus b into a minus b, means x minus 1 into x plus 1 divided by x plus 1 whole square it is, plus 2 divided by x plus 1 whole square into dx. One time x plus 1 get cancels out. We have integration of e raised to x into x minus 1 by x plus 1 plus 2 by x plus 1 whole square, integrating with respect to x. Okay. Now is it in the standard form or not? Yes, it is in the standard form, where f of x is equal to x minus 1 by x plus 1. Differentiating the function with respect to x, f dash of x is equal to, it is in the form u by v. How we differentiate u by v? V as it is, differentiation of u minus u as it is, differentiation of v by v square. We know that differentiation rule. Here x plus 1 as it is, differentiation of x minus 1 is 1, minus of x minus 1 as it is, differentiation of x plus 1 is 1, divided by x plus 1 whole square. Those who don't know the rule, those who forgot the rule, we have used that in differentiation part, and also it is there in the first PU. Please revise those. F dash of x which is equal to, this is x plus 1, minus will get multiplied with this, minus x minus minus plus divided by x plus 1 whole square, plus x minus x get cancelled. We have f dash of x is equal to 1 plus 1, 2 by x plus 1 whole square. You see, f of x is x minus 1 by x plus 1 and f dash of x is 2 by x plus 1 whole square. Okay. Here we write, we know integration of e raised to x into f of x plus f dash of x into dx is equal to e raised to x into f of x plus c. So similarly here for this question we have, that is integration of e raised to x into x minus 1 by x plus 1 plus of 2 by x plus 1 whole square into dx is equal to e raised to x into f of x, means e raised to x into x minus 1 by x plus 1 plus c. Completed. Okay. In the exercise 7.6, next problem, that is problem number 16 onwards, we will take it in the next class. Thank you.